In this video, we're going to look at rationalizing denominators that have two terms, and we'll do that using conjugates, or using the conjugate. Before we get into examples, I want to point out some notes. When we say two terms in this case, they're going to be separated by a plus or a minus. So we'll see addition or subtraction in the denominators here. We will only rationalize denominators with two terms that you have square roots. No cube roots, fourth roots, fifth roots, etc. And just like when we rationalize denominators with one term, we will still multiply by a form of the number 1. But when we have two terms in the denominator, our form of 1 will use the conjugate of the denominator. That's how you'll get rid of the square roots on the denominator. Okay, so let's see some examples. Simplify. Assume the variables represent positive numbers. So let's see here. So in this case, we're told to simplify, and the way to simplify this is, we notice there's a square root on the bottom. We need to get rid of that square root. However, if we were to multiply this fraction by the square root of 2 over the square root of 2, kind of like we did when there was one term, the issue becomes, if I did this on the bottom, I would have to distribute because of the minus. That's where I have two terms. You see, 4 and negative square root of 2 are my two terms. Since there's that minus, I would have to distribute my square root of 2. And what I'd end up with is 4 square roots of 2 minus the square root of 4. Well, the square root of 4, notice I'm not worried about the top right now. The square root of 4 is just 2. So if you'll notice, the square root that I had before now is gone. It's no longer a square root. But my first term is now 4 square roots of 2, and I still have a radical in the denominator. So this technique is not what you want to do when you have two terms on the bottom. Instead, what we want to do is multiply by a form of 1, multiply by a form of 1 made up of the conjugate of the denominator, 4 minus square root of 2. So the conjugate of that would be 4 plus the square root of 2. So what I'm going to do is take this fraction, 2 square root 3 over 4 minus square root 2, times by a fraction, a form of 1, and I'll multiply it by 4 plus square root of 2 over itself, because that equals 1. And what that's going to accomplish is, you'll see, when I multiply these denominators, eventually all the radicals should be gone. So on the bottom, multiplying conjugates is pretty easy. I take these two terms times these two terms. When you multiply conjugates, there's no middle term, and you'll see that here. So I'll distribute my 4 to get 16. I'll distribute my 4 to my square root of 2 to get positive 4 square roots of 2. I'll distribute my negative square root of 2 to my positive 4, giving me negative 4 square roots of 2, and my negative square root of 2 to my positive square root of 2, giving me negative square root of 4. And so you can see what happens is, the middle term, positive 4 square root of 2 and negative 4 square root of 2, cancel. So anytime we multiply conjugates, there is no middle term. They cancel out. Alright, so we'll work on the bottom some more later. Let's work on the top now. So I need to take 2 square roots of 3 and multiply it by 4 plus the square root of 2. And since there's a plus here, I have to distribute my 2 square root of 3. So 2 square root of 3 times 4 is 8 square root 3. And 2 square root 3 times square root 2 is positive 2 square roots of 6. I can't simplify the square root of 3 to the square root of 6. I can't split those radicals, so I leave the top alone, and I've got 8 square root of 3 plus 2 square root of 6 on top. And on bottom I have 16 minus the square root of 4, but the square root of 4 is just 2. So I have 16 minus 2. Well, let's keep going. I can certainly subtract 2 from 16. So I get 8 square root 3 plus 2 square root 6 over 14. And now I want to see if this fraction reduces. If you'll notice, the top is addition, and if I want to cancel anything, I need the top to be multiplication. And what I see is that 8 square root of 3 and 2 square root of 6 share a common factor of 2. I can pull a 2 out of the 8 and the 2. I can't touch the square roots, so I'll pull a 2 out, leaving me 4 square roots of 3 plus 1 square root 6, or just square root 6, all over 14. Now I have 2 times something on top, so the 2 here can reduce with my 14. So this becomes 1, this becomes 7, and my final answer is 4 square root 3 plus square root 6 over 7. So this fraction is equivalent to the original fraction up there at the top, this 2 square root 3 over 4 minus square root 2, but there are no radicals in the bottom. And that was our goal. Get the radicals out of the denominator and, of course, simplify the fraction as far as it would go. Alright, so these two fractions are equal to one another, and this one has no radicals in the bottom. The way we accomplished that was by multiplying by a form of 1 that used the conjugate of the denominator. Let's do one more example. Okay, in the last example we didn't have any variables, so I didn't have to say that the variables represented positive numbers, but here I do. You can see that we have x's. We have 2 terms on the bottom, so what we'll do is we'll take this fraction and since there are 2 terms, the way to make sure there are no radicals on the bottom is to multiply by a form of 1 that uses the conjugate, which is square root of x minus square root of 5. And I have to do the same thing on the top because the red fraction has to equal 1. Now the multiplication here is a little harder. Let's do the bottom first. I'll take square root of x times square root of x to give me square root of x squared. Square root of x times negative square root of 5 is negative square root of 5x. Then I get a positive square root of 5x. Again, we can see that those are going to cancel. And I get a negative square root of 25. Now on top I do the same thing. There will not be any cancellation necessarily because these are not conjugates. So I'll distribute my 2 square root of x to give me 2 square root of x squared, negative 2 square root 5x, negative 3 square root x, positive 3 square root 5. Okay, now it looks like a mess, but as we know, the bottom cleans up rather nicely. These cancel because one's negative and one's positive. Also, the square root of x squared is x, right? The square root of x squared. Oh, sorry about that. Trying to use the highlighter here. Square root of x squared is x, and the square root of 25 is 5. So I get x minus 5 on the bottom, and that's all I'm left with. No radical. On the top, however, I have 2 times the square root of x squared. The square root of x squared is x, so this is 2x, minus 2 square roots of 5x, I can't simplify that at all, minus 3 square roots of x, I can't simplify that at all, plus 3 square roots of 5, and I can't simplify that at all. I could try to maybe factor something out on top, but they don't have anything in common, so I'm done. It looks very messy, right? But this fraction is equal. These two fractions here are equal. This one has no radicals in the denominator. Now this idea of conjugates only works with square roots. So again, this idea of conjugates only works when rationalizing 2 terms with square roots. No cube roots or fourth roots. It's a much more complex process in those cases, but I just want to point that out. So that's how you rationalize denominators with 2 terms. I kind of like it because you always use the conjugate. It's just straightforward. You just do it. The multiplication can be kind of nasty, and your answers may not look very clean, so that can invoke doubt as to whether you did it properly or not. But when you have one term, it's a little harder because you have to decide what to multiply by. It's a little different every time. So anyway, that's how you do it, and I hope you got a lot out of this video.